Woohoo! Here we are.
Hello, lovely people. We're here again. Welcome everyone to episode 3 of the Data Mix. You've got two people on your screen. You've got me, Brian Booden, over here, and you're over. Which way are you? You're that way on my screen, George. You're over. Yeah, there we go. We've got my lovely co-host George Beaton here. So, guys, we're delighted to be with you. We've had a little bit of a hiatus while we all have our summer holidays, but it's an absolute delight to be back. Look, we'd really like to hear from all of you in the chat. So let us know where you're from, what you're doing on this glorious Wednesday afternoon. Well, in Scotland, it's glorious anyway. And we're delighted to have you here for episode 3 of the Data Mix. Now, first of all, a little apology. You sort of saw in our promo video, I managed to get the date wrong on our caption, George. You spotted that deliberate mistake, right? Because that happens to me every so often where I just get my dates wrong. So if you turned up on Wednesday, the 27th of July, which isn't a real day, sorry, but we are here and we're back today as well. And as you can see from the caption there, we've got Claudio Calvino with us today, who we're going to talk a little bit more on in a minute. But first of all, George, I'll pass it over to you for a minute, mate. How are you doing?
I'm doing pretty good, thanks. I noticed you said it's sunny in your part of Scotland. It's sunny for now in my part of Scotland, but it only has been for 2 minutes. We have been dodging the torrential downpours today, which is kind of makes me feel good about Scotland again. When we get more than about 3 days of sun in a row, something's wrong. So we're back to rain showers and warm summer rain. So I'm happy about that.
Yeah, it's always a bit disconcerting when we get into heatwave territory, isn't it? You know what?
Yeah.
I actually came back from holiday when I was in near up near Malig last week, and we managed to completely miss the good weather during the whole week. And on the day that we left, out came the sun. So I don't know whether I'm feeling aggrieved or not with the weather at the moment, but I think it is quite a key point because obviously we understand that everyone is hopefully looking forward to their summer holidays at the moment. And if you're a really, really lucky person, this might be the last thing you do before you go on your summer holidays. So we hope to give you something enjoyable to kick off with.
Yeah.
So,
And if you're
yeah,
in the UK, come to Scotland. We've got everybody needs to staycation this year. We
yeah.
have room in Scotland. Come here and enjoy the warm rain.
Yes, yes, we're practically tropical now, which is amazing. So,
Yeah.
but look, we've chatted the chat about the weather, which continues to be not bad overall. But the real reason we're here is obviously for episode 3 of the Data Mix. We've had our first 2 episodes have been barnstorming. Frankly, we had Steve Wexler, which seems like a long time ago, in episode 1, talking about visualization, and Scott Taylor, the data whisperer, in episode 2, who gave us the lowdown on data management. So it's another little swerve in another direction for us today, George. And I think this is
Yeah.
going to be a particularly interesting session for us as BI guys. So with that in mind, I'd like to introduce Claudio, who's joined us for the call today. Claudio, how are you?
Hey, Claudio.
Hello, guys. Thank you very much for inviting me. I'm good. It's raining. I'm cold, so it's perfect.
Oh, yeah, yeah, yeah. We can gather from your accent that you're not from Scotland. We're used to it, but maybe you're not. So, and George, you obviously know Claudio fairly well. Do you want to tell us a little bit about that?
Yeah, so Claudia and I have worked in the same team for the last 2.5 years. That's how long I've been at FTI. At FTI, actually, the digital science overall team is split into 3 different capabilities. And Claudio heads up data science there. He's had another recent move within FTI, but he's still so we still speak to each other, but we're not technically in the same team anymore. But yeah. Data science is something that I think a couple of years ago it scared me a little bit. I could see it was starting to creep into what I was doing in data and data visualization. Maths was never my strong point. Statistics was never my strong point. So when I started to think, okay, at some point I'm going to have to start thinking about data science, it scared me. But Speaking with Claudio's team actually demystified it a lot for me, so that's been really good, and I think because a lot of our regulars here have come from a data and data visualization background, I thought it would be really useful to have somebody in to talk a little bit about data science. What's coming down the line, what we need to do to get ourselves ready within the data and data visualization communities. So yeah, I'm really happy to have you on, Claudio.
Thank you, George. Thank you. I hope to be helpful.
I think you will be.
Thank you.
Yeah, I second what George has said there, Claudio. I think, as I mentioned before, this is going to be an interesting session for us because we'll be learning stuff, and that is legitimately true. We're not really data scientists or machine learning analysts in any way, shape, or form. So this will be a fascinating session. So I wonder if we could just sort of kick off a little bit, Claudio. I think there's only one way we can kick off, and that's to talk a little bit about your accent
Yeah.
and where that country originates from, and maybe, if you don't mind, just a little bit, just a few seconds on this, because this happened, right? So, and you're Scottish, and you beat England, and there's a lot of tension in the room that everyone just needs to get out, so that's all under the carpet. But how are you feeling after Chiellini and Bonucci lighting it up in the final of Euro 2020?
I don't know what are you referring to. I have no idea what happened.
Oh gosh, right. Well, we're taking a serious misstep here, George. I think we should just end it.
No, Claudio predicted this. Of course, you predicted this. You're a data science genius. You would have analysed all of the stats. You would have known that Italy was going to win, surely.
Never bet on your team. This is the first rule of never bet on your team. So it's no look. It did happen. It did happen, and I'm sorry. I'm definitely sorry, guys. I'm sorry for that. It should have not happened. It's coming to Rome. What are they saying? It's coming to Rome.
Yeah, I think on our last episode, Claudio, I was slightly groggy the day after the night before, where we had been ceremoniously dumped out by Croatia. So it's interesting to see that England went all the way and pushed. I have to say, pushed Italy very, very hard, especially in the first half. But I think the joy on some of those Italian players' faces as they played the game was just a testament to when you love your job, you love your job, right? And I think that's the thing that we saw out of Euro 2020 is so many people love their job when they're doing that out on the pitch. So a great achievement for Italy, and congratulations.
Thank you very much, but I would move the focus on the Olympics. You are doing great. You're winning a lot of medals, a lot of nice people performing very well. So I would move. Football is a news of yesterday. Today the Olympics are going on, and I think it's going very well.
Yes, it is. I think that the timelines haven't really worked out that well for us, obviously, because of everything happens through the night. So it's a bit of catch up everything in the morning. But it's great to have the Olympics there in some shape or form. Maybe not with the audiences that we're used to, but it's nice to see these events coming back in terms of the pandemic. It's been a journey.
Yeah.
And I think that's a really good entry point into what we want to talk about today. I think data science, I'm sure you will lay testament to, Claudio, is a journey in itself. So why don't you tell us a little bit about your journey and how you've kind of ended up in this type of area as well?
Nicely brought back on track, Brian.
Thank you, George. I've been working on that.
I was noticing on the comments
we're a
little bit tetchy there. So fantastic. Yeah, over to you, Claudio. Tell us a little bit about your history and how you got into data science.
Yeah, my history, I think it's I don't know how did that happen. I think it happened mainly because data science was a new field, and when the field is not mature enough, you have a different number of entry points. When you have a mature field, then you have few doors that you can open. When something is not well defined, you can enter the field from different perspectives. And my entry point was from academia. So I was a researcher before. I was doing my PhD in Italy, then Oxford called, I moved to the UK. After my year as a researcher in Oxford, at the Oxford Internet Institute, where I was studying the distribution of geographical phenomena mainly social media footprint. Me and my wife were having a chat, and she was suggesting maybe for me to apply to a different kind of job in the industry. And that this happened. I sent one CV. Kantar Media at the time was looking for a lead data scientist. I applied. They hired me, and this is how I did enter. The field now will be much more difficult. My background is not that technical. I am a geographer by background, political science, my master and my bachelor degree. So now it will be very, very, very difficult for someone like with my background to enter the field. This also meant that I had to specialize very quickly. I move very quickly from doing stuff to learn how to help people doing stuff. So now I would be useless. If you ask me to code, I would be useless. I would be really, really bad. And my team, they don't allow me to code anymore. Oh, George, I like that.
I just found out how to switch on the my proper camera, my HD camera.
It's a pro move, yeah. So they will not allow me to code anymore because they are quicker, they are better, they know what to do. But then I learned, how to bridge between the business and the technical side, how to bridge between the non-technical element and technical element, and that was, I think, a lucky move. I think it was a smart move. There are a lot of problems in making sure that the complexity of AI, machine learning, is really clear to business operators, and this is where I do have a role, and also in managing the team, growing the team, and making sure that weird people that are data scientists have everything they need to perform and deliver.
I think that's key, isn't it? There's a big differentiation between actually understanding the innards of machine learning and data science and having the experience and the skill and the past knowledge to be able to guide people into that area and give them advice and consultancy in terms of what to do. So how was that transition for you? How did you find that transition from the coding part into the consultancy part? Because I think that relates to a lot of the people on this call. They've gone through or are going through that kind of journey just now.
Look, in my case, I think it was driven by the need to survive. I had to survive, and I had to understand that the industry was becoming very competitive. One thing is to write an algorithm once, and then to have something that works. A different thing is to deploy a solution at scale. You need different skills. You need different kind of background. So in my case, it was not really a choice. It was just to understand what was happening and to decide to go in one direction. Data science then is also a very broad field. So you have just defining who data science is not really easy. It's not that easy. So you have people that are very technical from a software engineering background, people like me that are not that technical but able to bridge and to be a little bit like storyteller. I know that Felipe Mattei is on the call, and he's the king of storytellers. This is very much the two ends on the spectrum. And because I was already sitting on one extreme, it was kind of natural for me to move into a more client side kind of role.
And how did your kind of academic background serve you during that time then and accelerate that process for you, Claudio? Because obviously you've been involved in multiple publications in the past, and we'll go on to talk a little bit about your specialism in geo type analysis. But how's that process kind of been for you then, and has that really helped being involved in that academic background heavily?
Yeah, I think it does help. But the fundamental that you need to have to be in academia is very much the one, to pose yourself with questions and to challenge yourself with questions and then to find a solution. Felipe just commented. I like that. It's very much that kind of approach. So you learn how to code in R because you want to find a solution to a problem, and then you upskill and then you move into Python and stuff like that. It's mainly this kind of fundamentals that you need to have. So, and this is something that in academia is kind of common. It's not that natural and not always that natural. Sometimes in academia you tend to have people that are not that pragmatic, people that like to spend a lot of time on the comma 0001, which is not something that match very well to my kind of approach, and that is not really sustainable in the industry. So I think it's, you need to, some elements of having an academic background can help. Others could be a limitation. When we hire, now it's different, but in the last, at the beginning when I started hiring, I was always little bit, not very sure about hiring people with a heavy academic background, because not always this transition is easy. It's not easy for someone that has spent years researching a topic to have to deliver a project in a few weeks. It might be a problem, but it's true that when you have spent years doing your PhD, researching and learning, studying, and you have this kind of inquisitive approach, that does help a lot.
It's interesting. Claudio, then, I'm sort of going back to basics a little bit, but as somebody that's come from very much a BI consultant background, and I did work for a while in academia. So I worked for 5 years at the University of St Andrews, and I could certainly see there that we spent a lot of time theorizing about in general, the way to work with data, the way to talk about data. We had a lot of time to try out techniques to make up our own methodologies, etc. So I'm very grateful for these 5 years at the University of St Andrews. The pace certainly wasn't what it is in consultancy, but what we did get from there was the time to start thinking about data in a completely different way that you would if you were actually on the ground, actually having to deliver a project. But now it feels like, coming from a data and business intelligence background, where we're now being asked by clients to think about, for example, okay, you've shown me historically what my data looks like. You've pulled out analysis. You've given me some information. What does the future look like? And then they start asking us questions about artificial intelligence, machine learning, data science. As a complete newbie, how should we be talking to clients about these topics? Should we just be handing it over to the professionals, or what's your advice for us?
Look, I think that is there's a kind of moving target here. So a few years ago, you were expecting people not to understand the differentiation between AI, machine learning, deep learning, and so on. Now, it's so common that I would expect everyone that works in similar fields to have an understanding of what is the difference between these few concepts. Unfortunately, most of the time the client has no idea. They know the words; it's still a buzzword, and they are maybe they have budget behind this buzzword, and they need to be assured that the solution they're buying does have an AI component. And I think as consultants or as experts, our role is very much to help the client. And the first thing is to educate the client. We do educate our clients, because an educated client is a better client. And the first thing is to make sure that they understand the definition, not the definition, but the differences between AI, machine learning, and neural networks, and deep learning, and they do understand that sometimes these words are just used like it's just one word, but it's not really true. And that sometimes business do say that they do an AI, but in reality, what they do is maybe narrow AI, or is mainly machine learning. So the important thing is that we make sure that the client does understand what we do, what other companies can do. Like sometimes you are pitching a client, and they say, okay, this company is offering me AI. In reality, they're not offering you AI. They're just not that nice to explain you that what they are selling is a machine learning based solution, which is what maybe we are offering you. And that asymmetry is a kind of a problem. A few years ago, that was more than a problem. Was a limitation for the industry, because you would have, even big kind of companies, big players, telling that they were doing AI, and they were not doing anything. They were just doing rule-based models. Now, don't take me wrong, a rule-based model can be totally fine. It's can be the best solution for the problem, but one has to be straight about, one has to be honest with their client. So what I would suggest is, just to clarify that AI is a science. It's the science of making a machine behaving like a human being, an intelligence machine. Then there is machine learning, that is a part of AI, is a component of AI, is an enabler of AI. And then there is, the neural network is a kind of machine learning, and then deep neural network is a kind of neural network. So this is a kind of concentric circles that you want to have. An algorithm that is able to recognize pictures, for example, can be supervised, can be unsupervised. This, I don't define that as AI. Maybe in literature you would find people that define that as narrow AI. So it's an algorithm that is very good at one specific task, but that will not be able to do anything else. So what DeepMind does, for example, they are mainly narrow AI. So they are very smart algorithms. They do perform specific tasks. But if you ask the algorithm to do something that is outside what they have learned, they don't behave like a human being. So I would suggest to have this concept clear, and then to make that clear to the clients. There is not. I think that nothing good is coming from a client that expects to have something that is not yet there.
So that's actually quite important, is setting client expectations. And I think more and more we're seeing in the product suites that we are used to using, you get, for example, Click's Insight Advisor, they come out with buzzwords like conversational analytics, and they sound good. And, at every new release, they get better and better. But is that the same as AI, when we're seeing this sort of branded on top of products like that?
Look, I think that they are all machine learning based solutions. So they will have some kind of time series model, and they might be very good at performing few tasks. The problem with this kind of embedded solution is that they need to build a solution that satisfy a huge amount of clients. All their clients, they need to use just one algorithm. And in reality, that does not always work. So the data scientist does exist because it is our job to understand what kind of algorithm performs better in each single situation. So it might be that an algorithm that works very well to understand if your trend in selling ice cream, is the same algorithm does perform very well in predicting ice cream and does not perform very well in predicting some different phenomena. So I would always be careful, to trust 100% trust embedded algorithm on off-the-shelf solutions. They can work. They might work perfectly fine if you have, maybe noisy data, or if you have few data points, or if you have variables that do not make a lot of sense. Then you can end up with results that are not trustable, and then you end up having problems. So the short answer is low code, no code, great. Create a commodity out of data science, fantastic. But always, be careful, and maybe ask the expert, to validate whatever you are doing.
And I think I just wanted to latch on to something you mentioned earlier there, Claudio, and it was to do with, I suppose I wanted to ask a little bit about the education and data literacy. So I'm using BI level terms here, and this is something I want to discuss with you. So the BI industry over the last 5 or 6 years has gone through a bit of a flux and a bit of a change, in that it's not just all about the tooling anymore. It's about understanding your data infrastructure in your organization, and education and data literacy programs. We've seen them rolled out from all of the major BI providers to try and get a piece of this market. Now, that's all well and good when you're dealing with a BI and a tool effectively that you can see and play with and pull a chart onto and understand where that data is manipulated from. But how do those concepts sort of translate across to the machine learning and data science types of environments? So you mentioned that you have to advise the client correctly, but are you sort of seeing any emergence of any of these types of programs from a data science perspective, or is it very much a case of you still have to specifically train to become a data scientist or a machine learning expert?
Look, it's a very good question, and I think the answer will change in few years. So every team that I have built and led, they have never relied on just one kind of background. Computer science is for sure one background, but then I am a geographer. People with math background, physics, and so on. This is very much because what I believe our job is to answer, to find answers to questions and to solve, to find solutions to challenges. And when you have different backgrounds in a team, then you have different ways of looking at the same problem, and then you have different potential solutions. And this kind of dialectic generally brings to the table the right solution and helps delivering the best solution to the client. So what is important is for sure that you need to have people in your team that are able to understand what is the math behind the algorithm, what is the machine doing. You cannot deliver a black box to your client anymore. That was something that was possible in the past. Now it's not possible anymore. You need to make sure that you can explain what is happening, and that your algorithm is able, to explain to the client what's happening. The moment you deliver, the client won't understand which variable is doing what. And this is a very, very important element. So you want to have people that understand the math, understand the complexity of the algorithm, and this is why you have machine learning engineer. Then you want people that are also able to optimize your solution. So we have algorithms now that are very, very expensive in terms of computation time and resources. Every deep learning algorithm is really, 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 really expensive. And sometimes, you can build an algorithm, but then can you deploy at scale? So you need people that are able to optimize the infrastructure. And you need people also to be able to deliver to the client the right information. So I think that there is a new business, there is a new opportunity for people to make money in education, that is to come up with a data science program. And you can see there are tons. I would not always recommend, to go through this path. I will just, recommend maybe to trust what if you come from a different field, not to see that as a limitation, but to see that as an opportunity. So I will just, if you can code, and if you like coding, and if you are up for a challenge, and if you are happy to upskill and to go to the learning curve, then I would really suggest to enter the field, to try to enter the field. And again, data science is a very broad spectrum. Not everyone needs to understand the math behind the algorithm. Few of them needs to. Everyone needs to have an understanding of the math involved, but not everyone needs to understand every single line of the algorithm. Does that help?
Yeah, that makes sense. I'll put you on the spot now, though. How long before we get a no-code, fully AutoML product out there?
But you have already, you have already some of them already. I'm not going to say name because I don't want to have problems after the code. But I can see already some of them. But then you have the same kind of problem. So you have the same approach applied to every single problem. That my work or might not work. So the way I would suggest that maybe kind of sustainable development would be an AutoML solution provided by a data science platform that is managed by a data scientist. So this is the way I can see that working. I can see the tool, enabling the specialist. I'm still concerned. I will still be concerned about a fully AML solution in the absence of someone with an understanding of what the machine is doing. But I think they're already there. A couple of companies are already offering this kind of solution. No, George, am I wrong?
I think this is a really interesting point to just stop on, because I think certainly from what I've noticed in my career in BI, and maybe you guys have had different paths, but I think there's a certain point and a certain level that you can reach by following courses and doing things the right way and having education within a topic before you actually start to reach a plateau of a level of problem that you can't really solve without having that deep understanding and or that practical knowledge of working in a field. So it's great sitting in a classroom or following a course and following it from A to Z and 100%ing it and getting all through that. But in reality, the practicality of working with real life problems and scenarios is the thing that pushes you right over the top, right? And that would be the thing that would worry me about fully automated solutions, is that inherently they are automated, which means they will never be able to deal with the full complexity of these really deep issues. So that's the sort of matrix type of argument that worries me slightly, is that we see it more and more in the BI industry that tools are trying to do more and more for us, and with good reason, to make everything more visual and make everything more automated. But there is a danger that, first of all, we forget how to do our fundamental jobs that include our human instincts to be able to say, well, I just don't feel that is right. So do you see any of that sort of parallel in the machine learning world in terms of the danger and the potential perils that are there as well?
Yeah, I believe so. I think that one of the main points is to make sure that the algorithm that you are putting in production, they are fair, and there is no bias. And that when you trust a machine doing that, and you don't take care of your data, the data that are coming, that are part of the algorithm, that is very much a possibility. So it's something that is becoming more important, and I think it's the right direction, the right thing. I think we discussed that yesterday.
Yeah.
It is important that we make sure that what we do, it's fair, and the kind of solution that we develop are not generating, are not biased, and are not creating any kind of problem that maybe we cannot foresee when we are coding. And I believe that this is going to be a main topic of discussion for the next couple of years at least. I would say that already when you had data scientists coding and creating algorithms, you will have people building things and doing stuff just because it was possible to do. And okay, how this is a very good question. So there are different ways. So one main element is the data that you are bringing into your equation. So there are different level of bias that you can have in your data. Even if you are working with survey data, you need to make sure that the way the survey was conceived, was built, is well balanced. If you have a demographic class that was overweighted, then you already have a problem. And then when you have a problem in your data, then your problem is going to create a domino effect. And no matter what you do, you just cannot really fix it. And this is why you need people with different skills. You need people that understand, not just computer scientists, not just, people with the math and physics background that are great. And, I have a few of them in the team that are fantastic, and I could not do without them. But you also need people that have, maybe more classical background and be less technical, that understand these kind of nuances. And then also, the way your algorithm is just processing the data, the way the algorithm is making decision. There are solutions out there that are allegedly, or maybe less allegedly, skewed when it comes to recognize particular ethnicities. Why? Because maybe these solutions were trained on data that were biased already. It's not the algorithm per se to be biased. Is the data that has been ingested. So and how do we make sure that we do not really create unfair solution? Is no, we take care of all the steps. We audit what we are doing. We accept other people to audit what we are doing, and we try to challenge each other, and we try to make sure that we don't do things just because the technology allows us to do things.
Yeah. It's a really interesting point, actually, Claudio, just around the unbiasedness and fairness of algorithms. And ultimately, if you, because of where we are in the industry just now, I guess a lot of clients would just, when we build them a solution, they will accept that what we have built them is potentially fair. There might be some tolerances of accuracy around that. But is there... What about? I know you're sort of pioneering, you're spearheading a group within FTI that are looking at the fairness and unbiasedness, if that's a word, of algorithm. Will there ever be a sort of independent body then that can come along and actually put their stamp mark on an algorithm or on a solution and say, yes, we guarantee or we certify that this algorithm is fair and suitable for the purpose that you're doing? Is that what the future holds?
That is a great question, George. I'd love to understand a bit more about the regulation of this type of technology moving forward. Great question.
So first, yes. So in FTI, we are bringing together, people that have the right background, people that are smarter than me, to try to bring to market an offer that is going to help our clients to, just making sure that the kind of algorithm that they have in-house, so they have both, they are fair and unbiased. There are regulations now in the US and in the EU. I'm not an expert in this field, so maybe I cannot really go into the detail of the regulations. But the fact that there is a regulation is a good thing, and we are going in the right direction. I don't know if in the future there will ever be a centralized body able to do a kind of ISO certification of your algorithm, but for sure something similar will happen. And I do think that there will be a lot of investigation into algorithms already in production. A lot of centralized bodies, launching investigations into tech giants when it comes to AI algorithm or machine learning algorithm, and there is no way this is not going to happen. It's just because the regulators is now interested in this specific area, and this is why as a consultancy firm we are very much interested in going to market with such an offer, and we have the right skill set. From a data science perspective, I think it is important that we arrive at a point where we have rules in place, and where we understand and everyone knows what is possible and what is not possible. So something like a Cambridge Analytica case, for example, I know that we go back a few years in time, and this, Cambridge Analytica, they were not doing anything too sophisticated from a data science perspective at all. They had the right data, and they just decided to do something because it was possible to do something. Now something like that will not happen anymore. If you have an head of data science in your firm with a little bit of experience, this person will never allow something like that.
Again, I think that's quite a defining point there, is that when you're talking about using these types of techniques internally for your business, that's absolutely one thing where it's an internal process. But when you bring in the worlds of commercialism and consumerism, and you start to roll out predictions that the whole world is going to see, and might, for example, influence things that you purchase. We all know about things like Amazon that suggest your basket, you filled it with this. Would you like these 20 other algorithms as well? I mean, that could potentially become very serious, right? If companies like that begin to be, investigated, because are their algorithms fair, and what defines fair in that scenario and unbiased? So I think that's like a fascinating differentiator of how AI and machine learning is used internally and externally facing in terms of with
Yeah.
clients and customers.
Yeah, but it's not really a kind of abnormal situation. So generally, you do have technology that goes ahead, and then the regulator tries to fill the gap. This does happen, and I think it's a kind of natural development of any technology field. So you have the technology goes ahead few years maybe, and then you have the regulators that try to set the framework and the boundaries of the same technology. It's normal. The important thing is that we are now at the point where we are going to have more boundaries around us.
Yeah, I mean the industry is it's moving so quickly, and I guess just as data people, we're being asked to do more and more, especially as these tools are put into our hands. Then with great power comes great responsibility, and also with great power we can make monumental screw ups very easily if we don't fully know what we're doing. It's a fascinating topic. I think it makes me want to just tread very carefully around this at the moment.
Yeah, I think it's a very wise move. Very wise.
Call the experts. Call Claudio.
Yeah, maybe.
Claudio, are you able to talk briefly about any of the sort of projects you've been involved in where you've used data and data science techniques then just to make a difference? I think it would be just quite interesting to put some sort of real world examples around the stuff that you do.
Look, FTI is a very interesting place. It's a very interesting place where to do data science, and I'm not really. This is not an advert. We are hiring, by the way. So if you guys are interested, please reach out to me. I'm very happy to have a chat. FTI, it's a very nice place where to do data science because of the different kind of problems that the company tries to solve. So. From restructuring to global investigations to reputation. So this is all things that we took care of. Of course, I cannot mention clients, but we have been working with Geographic Information, helping ride-sharing company in London transitioning to electric vehicles, and that was very much a GIS problem, was very much a problem where data science was applied to geographic information systems. That was, I think, a very cutting-edge solution. We have applied machine learning to global investigation, try to understand where, if an entity was shipping goods in a way that was not allowed. And in that case, you were talking about the anomaly detection kind of approach. Which is another very interesting field where to apply data science. We have also applied data science methodologies to reputation management, that is to help brands predicting if a risky event is happening and if this event is likely to become a crisis. So we do know that brands spend a lot of money in mitigating crisis, and a crisis can become easily unmanageable in terms of cost and consequences. So we have built a solution that is able to tell our clients in few hours before an event becomes a potential crisis. And if you ask the experts, they need 3-4 hours to mitigate a dangerous situation. We offer them 8-10 hours so that they have more time. So this is the we we have applied data science to a number of different fields, and this is why I think you need people with different backgrounds, because in particular in a company, in a firm like FTI, where you have a very broad scenario in front of you, a very broad variety in front of you, when you have different problems, you want to have a number of different backgrounds. But sure, we do a lot of NLP. We do a lot of application support, which is very much, we do a lot of
language processing. Yeah,
correct. We do apply NLP to structured and unstructured data, to formal and informal data. It can be email, memorandum, lab results, or can be social media data. So NLP is very much maybe 60-70% of our applications. We do have a lot of anomaly detections involved. We do a lot of neural network, a lot of social network analysis, which is very much try to understand how people connect to each other, who is saying what, who is representing what, and then we are trying to push the geographic element a little bit because of my background, a little bit because it is just there. In the industry, we do believe in the importance of geographic data when it comes to shipments, when it comes to fraud detection, when it comes to reputation, when it comes to immobility.
Yeah, because I guess one side of the coin is actually being able to mine that data and then pull insight from it, but the other side is the visualization of it. And if you're able to visualize geographically, then the explainability of that type of information is fantastic.
I agree, and maybe this is where I know that this is where we need to bridge, and we need to build more connection between data science field and your field, guys. It's important to accept that having a good solution, having a good algorithm is not enough if you are not able to channel the right information to your client. That's it.
That's a really important circle to close, because I see a lot of integration nowadays between these data science techniques and BI, actually, because a lot of the time the request is being propagated or consumed by the BI side of things. So it's quite difficult. You have to be very, very skilled to have that experience to do the whole thing in one domain or the other. You really do need that crossover, which talks to your in terms of the roles that you had before. I mean, it harkens me back to when I was closer to the beginning of my Click career, and one of the most interesting projects that I worked on was to do with cell phones and cell phone signals and geographic tracking of that, and just the sheer process that we had to go through to be able to chew through those latitude and longitude coordinates to make some kind of sense of what we're seeing. We've come on leaps and bounds, and that's really why I wanted to ask you a little bit more about your geo-based background there, Claudio. I mean, obviously that's come from an academic beginning, but what are some of the things that you've worked on in terms of geo-analysis? Because I've got to say, I'm always working with clients who say, I would like a map for that, please, without really understanding what the concepts are behind that and what the drivers and KPIs would be to be able to evaluate that. So tell us a little bit about your experience in that area as well.
Yeah, so my experience in GIS comes from academia, correct? My PhD is in economic geography, and in order to do what I was doing, I had to learn how to manage geographic data. The application now in industry are mainly in the e-mobility field. So we can see that there are a number of new players in the mobility industry, and mainly e-players, I would call them, from scooters to taxi and so on. And they do need to leverage this kind of information, and this is where we are trying to penetrate the market. There is also a kind of a growing demand of geographic information system skills when it comes to social media, when it comes to mobile, so to telco data. For example, few months ago, we delivered a solution that was it was a predictive maintenance solution to tell our clients if a tower was going to fail, and the model was a GIS model, because the location of the tower, because of the weather condition, were going to affect the likelihood of a failure. So if you think about it, every field can leverage the geographic information. If you have a phenomenon, a phenomenon is happening somewhere in the space, in a place, and if you understand, how this somewhere is going to affect whatever you are analyzing, this is something more that you can leverage for your model. When it comes to social media, it's more different, because it's more difficult, because not always you understand, where the information was created, and that can be a limitation. But also in that case, even in that case, there are solutions. If you think about mobile phone data, they ping us every 2 seconds, every 5 seconds, something like that, which is it's an information that is so granular, and a lot of data provider will apply what is called the rule of five. So they will aggregate data up to 5 people, and it's really, it's a very granular information. It's a super granular information. Being able to exploit, understand the geographic element does enable a lot of different methodologies.
And I think that's evident by the fact that we get emails from Google telling us where we have been over the last period of time. Oh, here's your Google timeline to tell you exactly where you have been over the last month.
I think you can still access this data yourself. You can still download the data from Google.
Yes. I think under GDPR, you have to be able to access it, all of it now, which I think is a pretty big download if you are willing to go through that. Through those hoops. But no, geo has always been something that's been fascinating for me. But up until a couple of years ago, there's been a real limitation in BI tools being able to handle that level of data. Not so much handle the size of the data itself, but to be able to drive insight from it. And I think that's where the predictive and the machine learning part of it really comes into its own, is that what can you leverage from having 10 billion points from 400 people? I mean, it's hard to wrap a KPI around that without knowing a bit more about how the data set functions and ebbs and flows. And I think that's where, for me, as an admittedly data science newbie and machine learning newbie, that's what's fascinating to me about this whole topic, is that you can really start to leverage those areas that you can't easily see on a map in a Click or Tableau or Power BI.
Yeah, you're right. I think that a map can be a great tool, but also can be a confusing tool if it's not done properly. So if you have 4 million points in London, in a map of London, so you do not have any information. It's just points. You cannot really get anything of that. So it's important to have people able to understand how to channel the information properly. But I've seen some of the work that you guys do, and it's just incredible.
Well, that's where the use of color, of shapes, of metadata all come in, so that the people that know how to do that can really add value.
Yeah, I'm almost colorblind, so I'm not really the best person. But yes, color palette, and also being able to aggregate data, being able to weigh data, to scale data in a kind of appropriate way. I think this is very, very, very useful. You see a lot of maps online where they just throw points in a kind of administrative boundaries. They make no sense. It's not really telling you anything more.
Yeah, I feel like the field is so new that there's so many tools out there, and there will be a rationalization over time, and the good ones will come to the top, as they always do.
I agree.
I think, the last part, I'm aware that we're running up to the hour pretty soon, but the last thing I want to mention here is really just the dovetail into public services. I've been involved in quite a lot of public services work over the last few years, and been exposed to people who do a lot of work in that area, in the NHS and police forces. And again, the conversation sort of takes a twist in a very sort of serious way when you realise that this is not just predicting things for the sake of it. It's not just predicting sales, it's predicting where crimes happen. It's predicting how many hospital beds are going to be consumed on COVID based on the last 3 waves. And I know people personally who are both involved in projects in those types of situations. And these are the kind of critical functions that we need to use as drivers to be able to drive our technology forward, because we're not driven by commercialism and consumerism, right? We're driven by what happens in real life and real life scenarios. So I think it's so important for us to grasp the technology in the right way and make sure that we pick our times to be able to get the right experts in to deal with those scenarios.
I agree. I think it's a very good point.
Well, just to wrap up then, I think we've got about 2 or 3 minutes left. Claudio, I would like to ask you this question. What does the next 5 years of data science look like? Where's the industry going? What should we look out for?
Oh, wow, you should have told me, I could have prepared for that. So I honestly, I don't know. I don't know. I would be dishonest. I think that there's been in the last 5 years a lot has changed, and if the same kind of change will happen in the next 5 years, we're not going to recognize the field at all. So there will be for sure a kind of, I think that low code, no code platform will be more common. There will be, I think, more data scientists around. Will be less unusual to have small team of data scientists even in small and medium companies. The field will be better defined, and I think that will help a little bit. Will help also people that want to enter the field. So it will be clear that you need to have some software engineering skills. Will be, maybe the machine learning engineer kind of profile will be defined even better, and I hope that there will still be a kind of melting pot of skills. I do hope that what I try to do when I build a team is going to be there in the next 5 years, to avoid to have the same skill set replicated over time. So I do hope that in the next 5 years we will expand the field, bringing in more people with maybe a background in history, background in philosophy, background in ethics, to be able to understand the nature of the problem, informing the solution. Is that going to happen? I don't know. I don't even know if I'm going to be in the field in 5 years. Look at me now.
Your algorithm is off, Claudio. You've got no idea what's going to happen.
5
all
years.
kinds of ironic, considering why we're here today. But yes,
I think so.
Yeah, fair answer though. Fair answer. So it sounds like what you think is AutoML is going to get bigger, more prevalent, and we'll have more people in the field, and the field will be more defined, which I think will be fantastic.
Yeah, I think so. I think you will have more platform able to offer solutions, and you will have more expert able to leverage these automated solutions.
Yeah, the field's obviously not going away. It's here to stay.
I hope so. I have a mortgage to pay.
For your own job, Claudio.
Just for my own job.
Yes. Well, look, Claudio, I think it's been absolutely tremendous to have you here. And I love the fact that we've managed to get through an hour without really mentioning the name of any algorithm in data science. That makes me very, very happy that we haven't had to go into that kind of very granular detail. But it's been an absolute pleasure to have you. Thank you so much for coming on to episode 3 of the Data Mix. And usually this is the point where we're able to say who's next on the show. So I am quite excited to be able to sort of put that information forward as well. And I've just popped it up on the screen here. George only found out about this yesterday as well, so we've managed to sort of put it together quite quickly. But episode 4 is going to feature Jason Krantz, who's the CEO and founder of Strategy Titan. Jason's very prominent on LinkedIn in terms of analytics strategy, and it's something that we haven't really looked at yet, George, is how do you kind of build that analytics strategy from the ground up, and how do you feel more confident in making those decisions using analytics and data? And I don't necessarily mean in an algorithmic way in the way that Claudio would talk about it, but how do you feel safe in the process that you're building a data and analytics strategy that works for your organization? And Jason is one of the kind of key lights in that area. So we're really looking forward to having Jason on. Again, tentative date of the 11th of August, but that is TBC and subject to change, and we'll let you all know about that on LinkedIn when that happens. So George, hopefully you've got a good level of enthusiasm for that going forwards. I know we're trying our best to plan our guests as we go. So
100%, yeah, and a little bit worried as well. I don't know how many analytics strategies I've sold in my career. So
you're going to be found out, George. You're going to be found out. Yeah,
exactly. Claudio, you've been a fantastic guest. Thank you so much for that education.
Thank you for inviting me. Thank you very much. It was nice. I enjoyed it.
Great stuff. Great stuff. So, all that remains for us is really to say goodbye. Hopefully you're enjoying the sunny weather that you have it. One final congratulations to the Italian team for the English people that are still on the call on the Euro 2020 chat. And look, goodbye from me, goodbye from George and Claudio, and we look forward to seeing you on episode 4 of the Data Mix in a couple of weeks' time. Thank you, everyone.
Bye.
Thanks. Bye-bye.